Hello and welcome to my video lecture. This is Professor Ashok Kumar and you are welcome to this online my video lecture series. Today we are going to discuss very much important chapter number 5, and that is gears. Actually this is consecutively third video lecture on same chapter gears. Part 1 and part 2 already I have discussed the portion of gears, and now part 3, in which specially we will discuss about some standard tooth profiles and some phenomena like interference and undertaking. So let's start. First of all, the very much important topic that we are coming across, and that is the standard tooth profile. Basically there are 4 types of tooth profiles or system are generally used in practice for the interchangeability for the various kinds of gears which are used for the power and motion transmission. So first and most important types of the standard tooth profile, that is 14.5 degree composite system. Basically this type of profile is made with circular arcs at the top and bottom portion, and the middle portion is a straight line. You can see from the figure a top, that means flank and top land, and the bottom surface or root are get connected with a little bit fillet radius, and in between top and bottom surface there is a straight line. So this identification mark of the standard tooth profile 14.5 degree. Secondly, the straight portion correspond to the involute profile and the circular arc portion correspond to the cycloded profile. So this is actually combination of involute and cycloded profile, and generally this type of profiled gears are widely used for the general purpose of the gears. After that, one more similar kind of standard tooth profile is there, and it is 14.5 degree full depth involute system. This type of profile is made straight line except for the fillet arcs. Look at the face and root surface, it is get connected with a straight line, and entire profile correspond to the involute profile. So therefore manufacturing of such a profile is very easy. But it goes to have the little bit interference phenomena to be produced while transmitting power and motion. Basically if we are talking about 14.5 degree composite system or the full depth involute system, in case of full depth involute system, interference is the limitation which is related with the 14.5 degree full depth involute system. Basically interference is the, we can say that the kind of the crushing of the root and the surface of the tooth profile, and which would be not happen in case of the power transmission. So in order to avoid that, we should go for the 14.5 degree composite system. If you are looking carefully both of the diagram, then the angle made by the surfaces of tooth profile, or we can say that face of tooth with the vertical line which is perpendicular to the pitch line or the pitch circle diameter is 14.5 degree. So that's why it is known as a 14.5 degree either composite system or the full depth involute system. After that, there is a 20 degree full depth involute system, the standard profile number 3, and of course the degree between face of the teeth and the line joining the perpendicular line to the axis of the pitch circle having the 20 degree. This type of profile is nearly similar as that of 14.5 degree full depth involute system, but there is a difference of angle only. In case of the 14.5 degree, there was a 14.5 degree of an angle, whereas in case of full depth involute 20 degree system, there is a 20 degree of the pressure angle. The increase of pressure angle from 14 to 20 degree that result in strong teeth, because strong teeth is needed especially for high power and motion transmission. So if you are increasing tooth angle, teeth will behave and become like a beam. or wider at the base. So ultimately there will be huge strength if you are increasing pressure angle from 14.5 degree to 20 degree. Similarly, there is a 20 degree stub involute system also is there, and as we know that in previous case like 20 degree full depth involute system or 14 degree full depth involute system, we have seen that an interference is the prime limitation of such type of gears. So in order to remove that phenomena of interference in especially for the 20 degree full depth involute system, it just minimized by removing extra addendum of a gear tooth which causes interference. Basically interference is produced due to addendum, a large addendum height. So in 20 degree stub involute system, addendum is decreased a little bit, and in that way we can have the minimization of the interference that is produced during the power and motion transmission. Generally 20 degree stub involute system are widely being used where heavy load required to be transmitted. Now after that, point number 2, that is length of path of contact. Look at the diagram first. You have given two gear, gear 1 that is pinion, and gear 2 is the gear wheel. Now you can see that there is a base circle, there is a pitch circle, and it is addendum circle. Similarly, all three circles like base circle, pitch circle, and addendum circle are also provided for the gear wheel 2. Now if you are looking carefully both of that pinion and gear wheel, then there is a pitch point P, and that is located, and it is common point of contact between both of the gears. Now the contact between a pair of involute teeth generally start to begin at point K and ends at L. So suppose this gear wheel and pinion is going to be rotated, and of course both of the teeth should be engaged at some point and disengaged at some point. So over here the K point K is the beginning of the contact of both of the teeth, and this is the L point through which the disengagement is begins for both of the teeth. So this is the K and L points which is actually beginning and ending contact point for these two gears. So Mn is the common normal at the point of contact, and it also represents the common tangent to the base circle of the gears. So Mn over here, it is the generally we can say that the common tangent between both of the gears that represent the kind of the tangent line between two gears. Now point K is the intersection of the addendum circle of wheel with common tangent to the base circle Mn, and point L is the intersection of the addendum circle of pinion and common tangent to base circle Mn and KL. Generally which is known as the path of contact. So ultimately over here M and N as well K and L, if you are calculating the distance Mn and KL, then it will be generally known as a length of path of contact. So the length of path of contact of two meshing involute gear is generally equal to length on the common normal, which is cutting by the addendum circle of the wheels and the pinion. Now the path of contact KL is the summation of the portion of the path of contact KP and PL. So entirely we can say that the entire path of contact KL is divided by two distance KP and PL. By summing up both of the KP and PL, you will have the path of contact. The portion of generally path of contact KP is known as a path of approach, whereas the portion PL generally referred as a path of recess. Now if we are talking about the pressure angle, then generally it is defined as the angle between common normal at the point of contact Mn and the common tangent to pitch circle at the pitch point TT days. So this is what about the pressure angle. Now before deriving the relation, let's have some geometric parameter to be discussed here or clarify here. Small r is that is the pitch circle radius of the pinion, as capital R is the pitch circle radius of the wheel. Small r suffix b, that means the base circle radius of the pinion, whereas capital R suffix p stand for the base circle radius of the wheel. Small r suffix a will be the addendum circle radius of the pinion, whereas capital R suffix a stand for the addendum circle radius of the wheel. Now radius of the base circle of pinion is O1 and M. That means O1 and M that you require to consider, and this is the radius of the base circle of pinion, and it can be easily calculated with the trigonometric relation like O1M is equal to O1P into cos phi. Of course O1P that is equal to, we know that is the small radius r, so O1 and P is generally over here O1 and P that is replaced by small r. So if you are replacing and doing simplification, you will have O1M is equal to r cos phi. Similarly, radius of the base circle of wheel O2N is also calculated like O2N is equal to O2P into cos phi. Once again O2N is equal to r cos phi. So over here ultimately from the right angle triangle O2KN, that means O2 and then N and then K. If you are considering this triangle by using Pythagoras relation, you can write like that: Kn is equal to O2K square minus O2N square. So ultimately we know that O2K is equal to radius of the circle, and O2N is equal to O2P cos phi. So ultimately it will become the r cos phi. So by putting that relevant value in this equation of Kn, you are getting that the Kn is equal to under root r square minus r square cos square phi. Similarly, you have to also consider one more triangle, and that triangle is O2 into P into N. So that means this triangle now you have to take care of, and just use the Pythagoras relation over here. By using the Pythagoras relation, you are finding that Kn is equal to O2k whole square under root O2k whole square minus O2n whole square, and once again O2 into k, that is equal to r into a. So once again if you simplifying more, you will have the O2n is equal to O2p cos phi, and of course O2p we know that that is the radius of the gear, so it is replaced by capital R. So ultimately your relation will become O2n is equal to r into cos phi. So by putting both of the values O2k and O2n in this Pythagoras relation and simplifying it, at the end you will have the Kn that is equal to under root r square r whole square under root r whole square minus r square cos square phi. Now if you are considering right angle triangle O2 of Pn, then from the triangle you will have the relation Pn is equal to O2p sin phi. Once again O2p is replaced by capital R, radius of the gear, so ultimately your relation will become Pn is equal to r sin phi. Now we already discussed earlier that the Kp that is equal to Kn minus Pn. So by putting the values of Kn and Pn, ultimately you are getting Kp is equal to under root r square minus r square cos square phi or minus r sin phi. So this is what about the relation of the Kp at the end we are getting. Now similarly, if you are considering a right angle triangle, that is we can say that ML that will be the under root O1L square minus O1M square. This relation will be obtained whenever you are taking the right angle triangle O1ML, but in that particular relation O1L that is replaced by radius of the gear, so ultimately O1M that will be always equal to O1p cos phi, and O1p again replaced by the small r. So by putting that value over here and simplifying that both of the value O1L and O1M, by putting that value in this relation, you will have ML is equal to under root RS square minus R square cos square phi. Now once again you have to consider one more triangle, and that is the triangle O1MP, and from that O1MP, MP is equal to O1P sin phi. Again O1P is equal to R. So ultimately from the right angle triangle O1MP, you are getting the distance MP is equal to R sin phi. Once you have obtained all the relation, then it's very easy now to calculate PL. We know that PL is equal to ML minus MP, and if you are putting the relevant value of ML and MP, you will have PL is equal to under root RS square minus R square cos square phi minus R sin phi. So ultimately now by putting all that value in the relation of length of path of contact, and that is equal to KL is equal to KP plus PL, and solving the entire relation, you will have first KL, that is equal to RS square minus R square cos square phi minus R sin phi plus RS square minus small r square cos square phi under root minus R sin phi. Further simplification will give us the relation like under root capital R suffix A square minus R square cos square phi plus under root small r square minus R square cos square phi minus R plus R sin phi. So this is what about the length of path of contact of the two meshing gear. Now similar theory we are going to discuss, that is the length of arc of contact. Generally the arc of contact is defined as the path traced by a point on the pitch circle from beginning to the end of the engagement of two meshing gear. As if you are looking back the figure that you have given for the theory length of path of contact, in that particular case the arc GPH is generally known as the arc of contact. So ultimately arc of contact is the kind of the path that is traced by a point on the pitch circle whenever two meshing gear is start to end, or we can say that the start to end for the motion and power transmission. That means meshing start and meshing ends. In between the two periods, whatever the path traced by the point on the pitch circle, if you are measuring it, it will be the arc of contact. Now arc GPH is basically divided in two parts, arc GP and PH. So ultimately the arc GP will be known as arc of approach, and arc PH is generally known as arc of recess. Now from the right angle triangle CO1D is always equal to contain the angle theta, and similarly triangle GO1H is also having the angle theta. So ultimately from that both of the triangles CO1D and GO1H we can have the arc CD is equal to R suffix B into theta, and arc GH that is equal to R into theta. Now from both of that relation we can have the ratio of arc, and arc GH upon arc CD that is equal to R upon R suffix B. Now just you have to replace this arc radius RB and putting that values of RB over here, so ultimately the relation will becomes arc GH upon arc CD that is equal to R upon R cos phi. So if we are converting this entire relation in terms of arc GH, then it will look like arc CD upon cos phi, because RR will be cancel out in that particular relation. So ultimately we can say that the length of arc CD is always equal to KL, and which is the length of path of contact. Now putting that value of that particular KL in above equation, we can have the arc GH is equal to KL upon cos phi, because we know that CD is equal to KL, so CD is replaced with the path KL, and which is the length of a path of contact. Now length of arc of contact becomes the ratio of KL upon cos phi, whereas KL stands for the length of path of contact upon cos phi, so ultimately equation will be KL upon cos phi. Similarly, length of arc of the contact will also we can say that divided into category of KL, two division of KL. One is the length of path of approach, another is the path of recesses. So ultimately entire equation will become the length of arc of contact is equal to length of path of approach plus length of path of recess upon cos phi. Now we know that the length of arc of contact, that will be the Kp plus PL upon cos phi, whereas the length of arc of contact, that is equal to Kp upon cos phi plus PL upon cos phi. So in above relation, if we are taking ratio of Kp upon cos phi, so it will be generally known as a length of arc of approach, and the second term, that is PL upon cos phi, generally it is known as the arc of recess. So ultimately we can say that the length of arc of contact is the summation of length of arc of approach and length of arc of recess. Generally it can be obtained easily, both of the length of arc of approach as well length of arc of contact from the previous relation of it. So by summing up, you will have the length of arc of contact. Then after third theory that we are going to discuss, that is the contact ratio, or we can say that the numbers of teeth in contact. Basically contact ratio is the ratio or the numbers of pair of teeth in contact is generally the ratio of length of arc of contact to the circular pitch. So we can say that mathematically contact ratio will be the length of arc of contact divided by circular pitch. And of course circular pitch, a relation for the circular pitch is equal to pi into m. So m stands for the module. So ultimately relation or the equation for the contact ratio will become length of arc of contact upon pi into m. Actually contact ratio is a real number, and it should be always between 1 to 2 for the designing purpose of the any gear teeth. While you are designing any gear teeth, contact ratio should be between 1 to 2. When contact ratio you are taking 1, that clear means that only one pair of teeth of two mating gears will occupy the entire arc of length GPH. In simplification, what we can say that when one pair of teeth is just entering into engagement, the preceding pair of teeth is just being disengaged at that time. But in place of the contact ratio considering 1, you are taking, if contact ratio is 1.4, then it clear means that when the one pair of teeth of two meshing gear will just entering into engagement, the preceding pair, that means previous contacting pair of teeth, is still in the contact or engagement. So by selecting higher numbers of contact ratio, it directly means that, during engagement of any pair of contact of the gear, during engagement of it, the previous or preceding the pair of contact will still in engagement if you are selecting the contact ratio more than 1. After that, there is a very much important characteristic or phenomena we are going to discuss, that is an interference in involute gear. Now, in order to have the constant angular velocity ratio through mating gears, it is always necessary that the common normal at the point of contact of meshing teeth must pass through the fixed point, that means pitch point. Generally, common normal is also common tangent to the base circle of gears. Now, at every instant, the portion of the tooth profile which are in contact must be involute, so that the line of action does not deviate from that particular points. So, if any portion of the tooth profile in contact is not involute, it may be possible that the surface in contact will not touch each other tangentially, and which results in the improper transmission of motion and power. So particularly in such a case where the surfaces are not in contact and touch with each other, especially tangentially, it will lead to have the improper transmission of motion as well as power. And in particular such cases, if you are finding then the relative motion between the tooth surface will not be proper, sliding motion, and it causes the transmission of motion will be a transmission of motion or even power will be very rough. So mating of two non-conjugate or non-involute tooth profile is generally we refer it as a interference. So ultimately we can say that interference generally produced due to not tangential action that is made by two meshing gears. Now look at the figure. You have given two gears which is in mesh, and a pinion with center O1 which generally drives the gear wheel having center O2. So this is pinion and this is gear wheel O2, center with O2. And now Mn is the common normal that we have already discussed in case of a previous slide. Mn stands for the common normal at the point of contact, and it is also common tangent to the base circle of mating gears. Now the point K is the point of intersection of the addendum circle of the gear wheel with the common tangent, and point L is the point of intersection of the addendum circle of the pinion with the common tangent to the base circle. Now one thing that you should to have in mind that is that if the radius of the addendum circle of pinion is increased from O1L to O1N, then the point of contact L will move from L to N, and when this radius is further increased, the point of contact L will be inside the base circle of wheel. Since we know that an involute can exit only outside the base circle, so therefore any profile of tooth inside the base circle will be of the non-involute type. So we can say that in such a profiles, in such a special case, cannot be tangent to each other, and the tip of the pinion would be tried to dig out or interface with the flank portion of the tooth, or we can say that meshing gears. So in this case, tip of the tooth of a pinion will undercut the flank portion of its meshing gear, and in that way it may be possible that the tip will remove the flank portion of its mating gear. Few material will be cut away, or we can say that they remove, and it causes, and the phenomena, interphenomena is generally known as interference. Whenever one more thing that you should discuss here is that when the addendum radius of the wheel is more than that of the O2M radius, then the tip of the tooth wheel will undercut the flank portion of the tooth pinion. So similar phenomena will happen, and it is also known as an interference point. Now interference can be avoided if the path of contact does not extend beyond the interference point like M and N. So there is a upper and lower limitation that you have given, that in order to avoid an interference, your path of contact of meshing gear should be not extend beyond the length of path of contact M and N. So this is what about an interference. After that, there is very similar phenomena happens along with the interference, that is the undercutting of involute gear. Basically, look at the diagram. There is a pinion whose base circle is more than that of the addendum circle. So in such a cases in which the base circle is more than the addendum circle, what happens? The profile of tooth below the base circle is non-involute, and in this case the profile of the wheel and the pinion will not be tangent to each other, and the tip of the wheel will dig out, or we can say that interfere with the flank of the pinion, and it goes to remove the part of material from the, we can say that bottom or the root side of the tooth surface, and generally it is known as undercut. So due to undertaking, it may be possible that teeth of pinion will become very weak, and undercutting will not take place if the teeth are designed to avoid the interference. So in order to avoid interference, if you are doing take care of the path of length of contact Mn, which is not path of contact is not extended beyond the length of contact Mn, of course there will be no interference, and if there will be no any kind of interference, of course there will be no any kind of undertaking. Look at the bottom side surface figure that you have given. Actually this is the three condition of the undercutting. Whenever the undercutting start initially, it will remove gradually material from the root side, or we can say that the flank side of the tooth, and still you are doing more operation and the gear teeth are working with longer period of time. One time comes that there is a large content of material to be removed from the bottom side of the tooth. So this entire phenomena should be not happen for any kind of gear paste which are messing with each other and transmitting motion and power. So dear student, entire lecture we have discussed a lot about the law of gearing. We have also discussed about interference. We have also discussed about undertaking. Of course we have derived the relation of length of path of contact, arc of path of contact. So the entire lecture part 3 we have discussed a few points, few key points and few derivation too. Thank you very much for your attendance to this video lecture. Thank you very much. Thank you.